Now here are a few examples based on change of base. In this question we have to evaluate log of 81 to the base 4 upon log of 9 to the base 4. Now if you look at the terms clearly, we don't know exact value of what is log of 81 to the base 4, because 81 is not any round figure power of 4, and so is with 9. But we observe that the two logs which are divided have the same base, so therefore we can use the change of base formula and write this as log of 81 to the base 9, and we know that 81 is clearly the square of 9, so therefore the answer is 2. Let's go ahead. Here we have to show that the expression on the left hand side, which includes the product of three log terms, and that should be equal to 3 on the right side. Right. So let us start off by simplifying the LHS. The first term we observe that it is log of 4th root of u, so clearly we can write that as u raised to 3 by 4 to the base v into log of, we keep v raised to 5 as it is for now, to the base w into the third term is log of, once again we see that it is w raised to 4 upon 5 is the 5th root of omega raised to 4 to the base u. Now using the property of log, whatever are the indices inside the terms we can take them down, so that can be written as 3 by 4 log u to the base v into 5 log v to the base w into 4 by 5 log w to the base u. Right. Now here we see that 5 can be cancelled, 4 also can be cancelled, so leaving 3. So we have already got whatever we want, so the remaining expression must get evaluated to 1. Now look at this, log u to the base v, log v to the base w, and log w to the base u. We see that all the three logs have different bases, so we can't use the properties of adding or subtracting on them, and moreover there is a product. So the property that we can readily use is the change of base. So let us convert the bases of all the three log terms into some altogether different base. So log u to the base v can be written as log u to the new base upon log v to the new base. Now there is no need to mention what that base is. We may call it as a, but it's really not required because we are going to use it for all the log terms. Second term is log v to the base w, so that is log v upon log w, again by changing the base to the same new base. And last term can be written as log w upon log u. So we see that here all the terms get cancelled and thus leaving 3 as it is. Right. So that is the RHS. Let's go ahead and solve the next sum. Here we are given an equation in logs and unknown x. We have to find the value of unknown x. Now if you look at the three log terms on the left hand side, we observe that the bases are different. Right? So here also we cannot directly add or subtract the logs using the properties. Moreover, the bases are not only just different, but they are related. We can see that 2 square is 4 and 2 raised to 4 is 16. So the bases 4 and 16 can be expressed as some powers of the base 2. Okay, so let us take a decision to convert all the logs to the logs having base 2. Okay, so therefore we can write first term as it is, that is log x to the base 2. Second term we can write as log x to the new base 2 upon log 4 to the new base, plus similarly the third term, that is log x to the base 2 upon log 16 to the base 2, and that is given to be equal to 21 by 4. If we take log x to the base 2 common from all the terms on left hand side, we have 1 from the first term plus 1 upon, what is log 4 to the base 2? It is clearly 2 because 4 is the second power of 2, plus in the third term the denominator will be 4 because we know that 16 is the fourth power of 2. Okay, and that is equal to 21 by 4. Therefore, simplifying further, we have log x to the base 2 into bracket 4 plus 2 plus 1 upon 4 is equal to 21 upon 4. So we can definitely cancel 4 from both denominators, and 4 plus 2 plus 1 is 7, so that 7 will get cancelled from 21, leaving out 3. So that is what we have got effectively is log x to the base 2 is 3. So therefore that means x is nothing but 2 raised to 3, and therefore x is equal to 8. That's the answer.